Hello everyone, thank you for giving us the opportunity to present our paper. Now we will present a paper on a performance analysis on patient severity score based on supervised and unsupervised learning. Our group members are Asir Abrar, ANM Sajidul Alam, Rimi Reza, Shalsabil Ahmed, and I am Tanvir Ahmed. Now, this paper presents an analysis that is aimed at predicting the severity of patients according to their electronic health records in a specific time span by implementing supervised and unsupervised machine learning techniques. The proposed approach analyzes the severity score prediction using an EHR dataset obtained from an open source platform. Um, Open source platform. The data pre-processing was done using tools such as OpenRefine to implement the approach. Different supervised learning algorithms such as random forest, XGBoost, LightGBM, KNN, CatBoost, and unsupervised learning algorithms such as K-means clustering, spectral clustering, Gaussian mixture model, hierarchical clustering, and principal component analysis are being used. The experimental results demonstrate that the supervised learning outperforms unsupervised learning on the dataset for the expected outcome. Now my next part will be presented by Rimi Reza. Thank you.
Thank you, Tanvir Ahmed. I'm Reza. I'm going to present the proposed model of this paper. So the goal of this research paper is to compare the performance of several machine learning models on a specific EHR dataset. The objective is to determine the influence of supervised and unsupervised learning on patient severity scores while identifying them. For supervised learning, we have used a random forest XGBoost, LightGBM, KNN, CatBoost, and for unsupervised learning, we have used K-means clustering, spectral clustering, Gaussian mixture model, hierarchical clustering, principal component analysis, etc. So firstly, I'm going to talk about the dataset. It was taken from Mendeley dataset. It is an open source platform for the datasets, and the dataset was collected from a private hospital in Indonesia, and it includes basically it contains patient's laboratory test results which are used to determine the future course of treatment, whether the patient is in care or out care. So in data processing part, we did data pre-processing in unsupervised learning approach. Basically, we scaled and normalized the data so that we can have an unbiased clustering result. So first, our first section is unsupervised learning approach. So as we know that unsupervised learning deals with unlabeled dataset, which basically it groups all the data points that are similar or distance or in a closer distance based on the distance algorithm or something like that. And for the algorithms, we have used our K-means clustering. Firstly, the K-means K represents the number of groups, as in the groups that we are distributing the data sets into. And for the analysis of K-means clustering, how many clusters we should use, we use the elbow diagram technique. So in this technique, we plot this elbow diagram for different cluster levels from 1 to 11, and we determine which cluster should be better for this K-means clustering algorithm, to implement this K-means clustering algorithm. Next, we have implemented hierarchical clustering. So it is based on a hierarchy of the datasets, and to determine the clusters, we need to use dendrogram. We implemented dendrogram diagram, which is basically, as you can see in the figure 4, we have plotted this dendrogram for hierarchical clustering. And there, as you can see, there is a blue line and a red line, which both of them are intersecting each other. And the number of point of intersections are the number of clusters we need to consider to get a better result in hierarchical clustering. Next, we have implemented the spectral clustering. It is an ED approach for breaking down large multidimensional data in smaller groups of comparable data in rare dimensions. Basically, we have implemented a PCA-based spectral clustering, where we actually firstly implement the PC analysis. We compress the data set into two columns, PC1 and PC2, and then we implemented the spectral clustering algorithm on this PCA data set. So as you can see, I have showed some diagram. Figure 5, figure 6, figure 7, and figure 8 are showing the spectral clustering. And then next we have considered the Gaussian mixture model. This is basically a number of, this is basically groups the data sets into Gaussian distribution. So next, as we have throughout the paper, we have also did some dimension reduction before implementing all of these algorithms, clustering algorithms, because too much input variables might cause chaos in the data set, and which might bias the result for clustering, and for unnecessary prediction might happen for clustering. So that's why we did dimension reduction. For this, we use correlation matrix. Basically, it is we have plotted the correlation matrix for the independent variables. Higher the correlation matrix, higher the value, lower the result. The result will degrade. So we have dropped all the independent variable that have those are highly correlated. So that's all from unsupervised learning approach, and the supervised learning approach will be continued by Asira Burr. Thank you.
Thank you, Miraja, for giving me the floor. We have used supervised learning algorithm on this data set. So at first we read the patient electronic record data, then we pre-process the data and cleans and normalizing it, then splitting the data into two parts, which is training set and test set. Then we implement the supervised technique, and then evaluate the performance. Then we again process the data through RCC, ROC curve, cross validation, UC confusion matrix, histogram plot, frequency check, feature selection, and feature engineering. We did some feature engineering. Then we implement the supervised techniques to the modified data set, and then we compare the results with one another and see what we get from the supervised learning algorithms that we used in this paper. The algorithms we used here is the support vector machine. I won't go to the description here. Then we use decision tree. Then we use some gradient boosting algorithm, which is XGBoost, AdaBoost, Light GBM, KNN, nearest neighbor algorithm, random forest, and CatBoost algorithm, and naive-Bayes classification. The highest score we get from random forest classification. We have used random star equals to 20 for every algorithm to make the training set and the test set fixed, so that they don't change throughout the algorithm we train or test. We train the 80% data and test on the other 20%. The result we get will be discussed by Sajidul Islam. Thank you.
Thanks, Abrar, for giving me the floor. And now I will talk about the result analysis. I will begin with supervised algorithm, and then I will talk about unsupervised algorithm, which we got by implementing them. In the supervised algorithm, we can see that from table 9 and figure 11, according to the accuracy score, the random forest performed the best, and on the other hand, if we focus on the precision score, the KNN algorithm was performing the best. But for both of recall score and F1 score, light GBM algorithm was performing the best, and that's why we can say that by implementing light GBM algorithm, we were getting the best outcomes rather than using random forest and KNN. And about unsupervised algorithms, in the figure 12, you can see that uh, if we focus on the accuracy score, the hierarchical 4, which means hierarchical clustering with agglomerative complete hyperparameter and after dimension reduction, it was giving the best output in according to accuracy score. And if we focus on the precision score, Gaussian 1, which means Gaussian mixture model before dimension reduction, it was giving the best outcomes according to precision score. And for both recall and F1 score, sorry, so for both recall and silhouette score, hierarchical 6, which means hierarchical clustering algorithm with agglomerative average hyperparameter, and after dimension reduction, it was giving the best performance according to both silhouette score and recall score. And in the end, according to F1 score, K means 2, which means K means clustering after dimension reduction, it was giving the best outcome. So from here we can say that the hierarchical 6, which is hierarchical clustering algorithm with agglomerative average hyperparameter, and obviously after dimension reduction, it was giving the best performance rather than the other algorithms. And for dimension reduction, we generated heat map and we dropped some features for our as our feature engineering, and we selected the other all the other features except hematocrit, hemoglobins, erythrocyte, MCH and MCHC, and which really improved the precision recall F1, silhouette and recall score for all of the not all of for all of the algorithms, but especially for K-means algorithm. So this was our insights from result analysis, and the rest of the part will be described by Salsabil Ahmed.
Thank you, Sajidul Alam, for giving me the floor. I'm Salsabil Ahmed. I'll talk about the future work and the conclusion of the paper. Our work shows performance analysis based on supervised and unsupervised classification techniques. We will try to improve the classification techniques in future by doing feature selection and feature engineering. Other dimension reduction techniques such as matrix factorization, manifold learning, and autoencoder methods can be used for this task as well. Also, similar studies may be performed on many EHR datasets or any COVID-19 pandemic-related EHR datasets to see how these algorithms perform on various datasets. To conclude, in our paper, a performance analysis of predicting the patient severity scores has been proposed and successfully implemented by applying supervised and unsupervised machine learning techniques on an EHR dataset. This analysis is designed and implemented with consideration of blood test report data, such as the patient's amount of hematocrit, hemoglobin, etc., and all the other measurements of different cells in blood. Our proposed approach can assess and forecast the severity of patients in cases when there is a shortage of medical beds in pandemics. In this case, instead of human brain decisions, our strategy can make things faster as it is an automated procedure. Patients with less severe conditions can simply be alerted about their health status and taken home. On the other hand, when patients are at high risk, their families can take required steps to improve the patient's position. As a result of our research, we discovered that supervised classification algorithms outperformed unsupervised algorithms in predicting patient severity score. That was all from us. Thank you for listening to our presentation. If you have any question, you can ask.